Let's say one. Okay, this is my YouTube channel, guys.
Okay, so the learning goal for today was to solve proportions using cross multiplication and set up proportions for similar triangles. So our first section is going to be all review of Algebra 1. So hopefully the first page will go quickly. And this ties in very well with our last section, which was dilations, because we'll see some similar triangles, which are just triangles that have been dilated. So a proportion is when I have equal ratios, or ratios that are equal. So for example, 3/4 and 6/8. If I reduce 6 and 8, what does that reduce to? 3/4. So that's why those are considered equal. But just to double check, we can use cross multiplication to check and see if those values are congruent. So to use cross multiplication, did you guys see that thing going around on like Instagram, Snapchat? It was like, how do you do your X? Did you see that thing?
Yeah, I seen that.
Yeah.
On Instagram.
So like I always draw mine like that. So that's the way I cross multiply. Doesn't really matter as long as you're going diagonally to do those. Does anybody draw theirs differently than that?
I've got a little chart look.
Well, there's just like one of my other students said he does this and like goes up. So like draw an X. Anyway, it's just weird. I thought it was interesting. Okay, so however you want to cross multiply here. So again, I just do it the way I'm gonna draw an X usually. So 6 times 4, and then 3 times 8. So when I multiply each side there, what's 6 times 4? 24. What's 3 times 8? 24. So if those are equal, then I know I have a proportion and equal ratio. So we can use cross multiplication just to double check that those are equal. Are we writing down notes? Okay. You just need to be writing down what I'm writing down. Alright, so we're going to practice. You guys remember cross multiplication from Algebra 1?
Yeah.
This should be all reviewed. Okay, so I'm going to, again, I just do it the way I draw an X. It does not matter the way you do it as long as you're getting the ones diagonally. So that's 5x. And then on this side, I'm going to do 6 times 15. Okay, so what's 6 times 15?
95.
90. Equals 5x. And then what's my last step here?
Find out X.
Divide by 5. So x would equal what?
18.
18. Okay, that's like a simple example. And you could have done that without a calculator, although I gave you guys calculators for today. Okay, looking at the next one, I'm going to do the same thing. So 3 times x, I can just kind of conjoin 3 and x together. But what's different about this side? What do I have down here in my denominator? I have another equation. Okay, so it's not just a value, it's an actual equation here. So you want to make sure your equation is inside the parentheses, and what do I have to do now? Distribute, very good. So some people were forgetting how to distribute. It has to be to both terms. So 6 times x, and then 6 times negative 6 would be negative 36. I'm moving through these quickly because you guys are good at this already. So I'm going to subtract 6x, start combining my like terms. So I have negative 36 left, and then that is a negative 3x. So when I divide negative 36 by negative 3, what do I get? Positive 12. Don't sound so enthusiastic. Okay, go ahead and try the last one. I'll pause the video so you can try that last one on your own, asking questions. Okay, so double check your answer. You should have gotten x equals 7. If you didn't, you can check my steps there. Okay, moving on to some word problems. These are still really simple, but we have to set up our own proportions. They're not given to us. Aiden? So the ratio of boys to girls in the class is 4 to 3. So the 4 represents which one? Boys or girls? Boys. Very good. It says there are 20, or if there are 20 boys in the class, how many girls are there? So remember, a ratio can be written with that colon, or it can be written in fraction form. So we need it for proportion, we need it to be written in fraction form. So the 4 represents the boys, the 3 represents the girls. So right now my ratio is boys over girls. So which one did they give me? 20 what?
So the 20 goes on top.
20 boys, right? So the 20 is going to go on top. Very good. We want boys over girls. If we are looking for the girls, what can I leave that as? X. Okay, and we should know how to solve that, so go ahead and solve that one. So go ahead and cross multiply and solve for X. 4X equals then 20 times 3. Okay, you should have had either 3 times 20 equals 4x or 4x equals 3 times 20. What is 3 times 20? 60. And when I divide by 4, 15 what? Girls. Very good. Okay, so that is a pretty easy example when they give you everything you need. If we look at the next one, tells me my ratio of boys to girls in the class is 1 to 3. But what does it give us here? It says there's 28 what? Students. That includes both boys and girls, right? So I'm going to label that as like my total amount of students. So if I look back at my ratio, that's representing boys to girls. I want to find the total that's represented there. So I'm going to add the number of boys plus the number of girls just in my ratio. So 1 plus 3 would give me 4 total. Are we okay with that? So kind of like what we did with our partitions, we find the whole number of parts there. So I'm going to do 4 on the bottom. So that's my total number of students because I know they gave me the total number of students there. And what are we looking for? How many what? Girls. So I really don't care about the boys. Sorry, boys. But I don't care about the boys in this problem. I just want the girls. So what number represents the girls? The 1 or the 3? 3. So I'm going to create my new ratio, girls to the total number of students. Are we okay with that? So the other side, I again want the girls over the total. So or am I going to put 28 on the top or the bottom?
Bottom.
On the bottom, it needs to go with the total. So we want girls over the total. If we're looking for girls, what do we leave it as? X. Okay, so sometimes it might help to label your ratio there. So let's go ahead and solve for that one. We'll have 4x equals 3 times 28. So I'll give you a second to solve that one. Hold up your answer on your hand once you have it.
It's like you can't do that.
I'll do it like this. That's what my tongue's at.
Okay, so how many girls are there? 21 girls, thank you. Okay, so those are two kind of, well, all these are easy, should be easy. The next one is more about geometry. So it says a triangle has angles in the ratio 1 to 2 to 3. So we have 3 terms in this ratio, which is fine. And it asks what is the size of each angle. Okay, so we can change this ratio into an equation by just tagging an x at each number. So I'm going to do 1x plus 2x plus 3x. I'm just making my own equation. And if we're talking about triangles, and their angles, what would I set these three angles equal to?
6 and 8.
180. Very good. Okay, you're not wrong, Aiden. It does, when we combine like terms, yes. We will get what over here, Aiden?
It's that's
Yes.
that's from algebra 2, man.
Combining like terms?
Yeah, that's all we do.
Alright. That's what we do in here too.
Yeah, this is easy.
Okay, everyone okay with why we set it equal to 180 here? Alright, so let's go ahead and solve for x. You don't need a calculator. 18 divided by 6 is what?
3.
3, and then we just
add a 0.
add a 0. Okay, that is not my answer. Why is that not my answer?
What is 1, 2,
3.
3?
What is the size of it?
Each.
Of each angle, right? So we need to find the measure of each angle. So what am I going to do with that value of x? Plug it in. So 1 times 30 would give me 30. 2 times 30 would give me 60 degrees. 3 times 30 would give me 90 degrees. So if these are my three angles, someone raise their hand and describe this angle. How would I classify this triangle? Sorry. Mason, you want to go for it?
I can't remember.
I could classify this two different ways based off its angles inside.
I saw some.
It's scalene because they're all three different. What about the angles? What kind of angle do I see here? So this is a right triangle. It's a right scalene triangle. Very good. If you care, you can write that down. Right scalene. Alright, so I'm going to have you, we're going to do number 4 and then I'll let you finish the rest on your own. So this is going back to our quadrilaterals. What's a quadrilateral? Four-sided figure, right? So I'm going to just draw a four-sided figure. It can look like anything. It could be messy. It doesn't have to be perfect looking. It just has to have 4 sides. Okay, it tells me the sides, or it gives me a ratio of the sides here. All I'm going to do is copy that ratio onto my figure. So I'm just going to start at the top and work clockwise. So 3 to 1, 3 to 1. That tells me how those sides are related. Okay, so right now, is it telling me that all of my sides are congruent? No, it's telling me that what sides are congruent? You guys are so good. My opposite sides are congruent. So there are two answers here. What type of quadrilateral could this be if the opposite sides are congruent? I'll pause the video here and let you think about that with your partner. Okay, so your obvious answer should have been rectangle. But there's one other quadrilateral that has opposite sides that are congruent as one of their properties. Haley, you're the only person I saw with it on your paper. Does anyone else want to take a guess before
Square.
Rhombus.
Okay, these, in a rhombus and square, what sides are congruent?
Oh.
All of them. So what's the only other one that's just opposite sides?
Wow.
Good, parallelogram. I know what you guys were thinking. Remember, like a square has all traits of, like everything. But in this specific case, we're looking for opposite sides that are congruent. Okay, so I'm going to let you guys try 5, 6, and 7 on your own or with your partner, and I'll kind of just walk around if you need me, but I think you should be okay. Just make sure you're reading what the question is giving you. So try those. Okay, so do we get 7.5 cups of powder for number 5?
Yes.
That one should have been easy. Another way that we can double check our answer is to use cross multiplication. So my ratio is 4/3, and then I said if we have 10 cups of water, I'm going to have 7.5. So you can cross multiply these numbers and double check. If you're ever wondering if you are right, these numbers should end up being the same. So that's just a way to double check your work over here. Okay, did anyone, I saw some people getting confused on number 6. Can someone tell me what their ratio was here? Of like juniors to the total? You should have done the total, Sergio. Very good. So how did we get the 5 there? Good. So I got 5 as my total. Why did we ignore the freshmen? Why do we not care about freshmen? it's asking for juniors. So we want only the juniors over the total number of students. So that should have been your setup. And how many juniors did we get? 27. Questions there? Okay, the last one. This was a little bit different because they gave me the sides of a triangle, not an angle. Did anyone set it equal to 180? Very good. What do we set this equal to? Good. To the perimeter. And what do we get for x? 3.5 was x, but then what did it ask me for? I heard lots of good conversation about it. The shortest side, so which one did we plug it back into? 3x, 8x, or 7x? 3x would represent my smallest or shortest side. And you should have gotten 10.5 centimeters. What if it had asked you for your longest side? Which one would you have plugged it back into? 8x, very good. Alright, so that was just kind of getting us warmed up with the whole proportions. Now we're going to apply that to our, oops, I didn't want to do that, to geometry. Okay, so here we have similar triangles. You'll see this little squiggle here. It tells me triangle ABC is, what do you think that represents? Not congruent, it is similar. If I have similar triangles. We're going to do a lot with similar triangles. There's theorems, kind of like our angle side angle stuff. There's a whole other set of those for similar triangles. So similar are not congruent, but they are the same shape, just a different what? Different size. So these have been dilated. That's why it ties in with our last unit of dilations. And this is called our similarity statement, which you can read like we did our congruency statements. So it kind of helps you pick out your matching or corresponding sides. So we're going to set up proportions here to solve for our missing sides. What we want to start with is always the set of sides that is already filled in, so that it does not have a variable. So I'm just going to start. It looks like 8 would correspond to which side over here? 8 would look like it goes with which one?
X.
X. And we can double check that. That's BA. So I'm going to read BA should be the same as what over here? DE, which is true. So those are going to correspond to each other. But that's not already filled in, right? I have a variable there. I'm looking for the set that's already filled in. So I'm going to look at 5. Where do we think 5 corresponds to? 2. Let's double check. It could either be 3 or 2, so let's just double check. BC should be the same as what? Looking at my similarity statement, BC should be the same as DC. So we picked the correct one there. So I'm going to do 5 over 2. You always want to pick the filled in one first, because we're going to use that for both of our proportions. So I'm just going to draw a line there. We're going to solve for x and then y. Okay, so we see that one triangle is bigger, right? So when I picked the side 5, was that for my bigger or the smaller triangle? That was from the bigger one. So I'm going to say this is, you don't have to write this every time, but just for the first one, please write that down. We're doing large triangle over small triangle. So my other proportion has to also be large over small. I always solve for x first. That's just like habit, I think. So I'm going to use 8 and x. Which one is going to go on top? Which one is from the bigger triangle? 8. So this should be 8 over x. Anyone have questions so far? Alright, so from here we should know what to do. What do I do to solve? Cross multiply. So let's go ahead and do that. I have 2 times 8 is equal to 5x. So you get 16/5, but let's go ahead and put that in decimal form. So divide that in your calculator. And what do we get for x? 3.2. Okay, we're going to use the same ratio to solve for y. You don't want to pick the one, like I could use 8 and now 3.2, But let's say like we got this answer wrong. If we use that one again, we're gonna get another wrong answer. You always just wanna like pick that first one and use it again. So I'm gonna do 5/2, so large over small. Okay, which means I have y and 3 left. And I like to just draw or like code mine, basically like do a different type of line so I can see my corresponding sides. So which one is going to go on top, y or 3? Y. So we have large over small. So let's go ahead and cross multiply there. Okay, you should have gotten 7.5. Anybody have questions with that? We can do small over large. That's fine. We just have to use the same pattern. So I can't do like large over small and then small over large. So you just have to keep that same pattern. And you'll figure out which way you like to do it. Okay, this one, we don't have a similarity statement, but do you guys see these little markings that they gave us? There's like dots and open circles. Those are just landmarks to use to show which ones are matching or corresponding. So maybe with your partner, find the ratio that's already filled in here. Okay, so kind of like our 5/2, which set of sides is already done for us? Just want to see if we can do that without me first. So double check that these little markings are going to show you which ones are first are similar. Okay, I'm looking for that like first initial ratio that's already filled in. Okay, I see a lot of 5/3s or 3/5. Let's talk about why that's wrong. So if I look at 5, it's from the center to the dot. So I need to find the same markings. From the center to the dot is which side? Not 3, it's 4. Do you guys see that? So you can't always just go with like the ones that are across from each other. Sometimes they're going to be right next to each other. So you have to use either the markings or the similarity statement. Does everyone understand that? I need to go over that one more time. So you're looking for the same markings, those dots. So 5 and 4 is going to be our first set. Did I do small over large or large over small? Large over small. So I'm going to do the same thing on this side. I'm going to solve for x first. So I know x is on my small triangle, so that's going to go on the bottom. And which one does that correspond with? It's in between the circle and the dot. So the circle and the dot over here would be what? 6.25. So I'll give you a second to solve for x there. And I would, instead of, you could do that in a second, I would just jump in like where we are right now. So you know, we're behind. Okay, walk around to see your answer for x, and then I want you to start setting up for y. We're going to use that same ratio of 5/4. Okay, you want to like keep writing it as an equation. So 6 times, or sorry, 6.25 times 4 is equal to 5x. If you're going straight across, you have to put that. So now do 6.25 times 4. So you can go away with. Okay, moving on to the last one. This one's a little different. My other class called this like the spotlight example or something like that. So it's when we have a small triangle inside of a big triangle. So these are a little bit different. I always do small over large here because I don't know why, it's just the way I do it. So the corresponding sides are easy because they share the same side here. So like AC is going to be the same thing as E on my big triangle. So if I just fill in that's already filled in for me. So I'm going to do the small over the large. So 1 over, what would most people put here?
4.
Most people wouldn't put 4. Most people would put 1 over what?
3.
3. Why is that incorrect? Or how do we get 4? I have to add both of those pieces together to get my large or my big triangle. So this should be 1 over 4. So I'm going to use that one twice, or on each example there. So 1 over 4. Those little brackets help me so I don't forget to add my pieces. So I'm just going to do the other side. I always just do these the same exact way. So my small would be 2, and the large would be 2 plus x. The most common mistake that I see with these is I would just write 2x there. So it has to be added together. So you're adding your pieces together. Okay, so this one, still the same thing, 2 times 4. And then 1 times anything, is that going to change my equation? No, so I'm just going to rewrite that as 2 plus x there. Okay, again, the most common mistake with these is that people would write 2x instead of 2 plus x. So make sure you're adding, not multiplying. So last thing, I'm going to subtract 2, and I get x equals 6. Questions? Okay, your other one, you don't have to add any pieces together because the whole line or segment is given to you. So our last one would be y and 6. Which one do I put on top? Good, I'm doing small over large, so I'm going to do y over 6 here. And go ahead and cross multiply and solve. Okay, do we get 1.5?
Yes.
Okay, flip to the back. I'm just going to have you try number 4 and number 6 on your own, since these are the same ones we basically just did, but I want you guys to try them on your own before you start on the prep work. So I'm going to walk around and check your answers for these, and then I'll let you get started on your homework.